Okay guys, welcome to Chapter 12, Lesson 2, Trigonometric Functions of Acute Angles. Now this particular lesson is filled with new vocabulary and gray boxes like this one that you'll have to memorize. So I'm going to show you page by page. We're going to walk through it this way, and then I'll bring in some exercises when we get to the examples. Okay. So first, you've got to even be able to say trigonometric functions of acute angles. The objective here is to define trigonometric functions of acute angles. So again, we're working on definitions and learning some new concepts. The application of them will be less challenging than understanding and remembering all of them. Okay, to define the trigonometric functions of an acute angle theta, so we're just going to pick the Greek letter theta and say that that's the angle we're going to care about. We're just going to name an angle theta, and it's going to be an acute angle. So in order to define the trigonometric functions of an acute angle theta, first place theta in standard position as shown in the diagram below. So here's the diagram. The initial side is on the x-axis, and the terminal side is rotated counterclockwise up into the first quadrant here. It's an acute angle. Next, choose any point P. Just boom, there it is, P. And it has the coordinates x, y, and it can't be the origin, so any point besides the origin on the terminal side of theta, and let r be the distance of the origin to that point P, OP. Then we're going to have these definitions. So notice the picture first of all. We have the origin here at O. We picked a point P. We have the theta angle with the terminal side. Then we're going to call this, it forms a right triangle. The long side across from the right angle is called the hypotenuse. The initial side is called the adjacent side. It's next to the theta angle. And then this is the opposite side of theta. And we've labeled the adjacent side with an x because it's as long as this particular value of x. And we're going to call the opposite side y because it's as tall as this particular point value. So we have hypotenuse, the adjacent, and the opposite sides. And then we've labeled hypotenuse with r, the adjacent side with x, and the opposite side with y. So you understand the picture. Okay. Now, the sine of theta. We're defining these words. We have sine, cosine, and tangent. The sine of the angle theta, which is written sin theta, so sine of theta, is equal to y over r, the opposite over the hypotenuse. The cosine of theta, written cos theta, is equal to x divided by r, the adjacent over the hypotenuse. And the tangent of theta, which is written tan theta, is equal to the opposite y over the x, over the adjacent. So opposite over adjacent, y over x. Now here's what's interesting. Now, and help you to remember this, because you'll have to remember this, is just use this handy dandy little memory tool. The sine of an angle is equal to the opposite over adjacent. So remember that as so. The cosine of an angle is equal to the adjacent over the hypotenuse. So remember that as ka, so ka. And then the tangent of an angle is equal to the opposite over the adjacent side. So toa. So remember, so ka, so ka toa. Sine is equal to the opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, now the ratios of x to r, y to r, and y to x depend only on theta. If you picked P anywhere, right, because it's x, y, then those ratios will not change. So since the ratios depend on theta, sine, cosine, and tangent are actually functions of theta. So they're functions. Notice that x, y, and r are the lengths of the legs and hypotenuse, respectively, of this right triangle OMP. The definitions can be restated in terms of these lengths, just like I showed you on the paper. The sine, the cosine, and the tangent can be related by the opposite over hypotenuse. So cosine is adjacent over hypotenuse, ka, and then tangent is opposite over adjacent, toa. SOHCAHTOA. So remember SOHCAHTOA, and you'll remember the three basic trigonometric functions of acute angles. Okay, so let's look at an example and see what we can do with that. It says an acute angle theta is in standard position. Okay, so remember what that means. And its terminal side passes through P, the point 4, 5. Find the sine of the angle, the cosine of theta, and the tangent of theta. Okay, so let's translate that. We have an acute angle in standard position. Here is the initial side on the x-axis, and it's acute angle, so we'll just stick it up there, and it passes through 4, 5. Oh, there we go. So it passes through 4, 5. So I just labeled that, I didn't even count it. And it says find the sine, cosine, and tangent of the angle theta. Well, if this is 0.45, how long is this? It's got to be 4, because it goes over 4. And how tall is this? 5. Now this is a right angle, so can we figure out this side, the hypotenuse? Yes. 4 squared plus 5 squared equals r squared, or c squared, we normally say. So 16 plus 25 equals r squared. So we have 41 equals r squared. So r is equal to the square root of 41. So this is the square root of 41. Okay. So what is the sine of theta, cosine of theta, and tangent of theta? Now, we're going to use these measurements, and the sine is the opposite over hypotenuse. So that's the sine of angle theta. The cosine is ka, adjacent over hypotenuse. And the tangent is toa, opposite over adjacent. So there, this one's done. These are not, because you can't have a square root on the bottom of something, so we do our little multiply the fraction by a fancy form of 1, and we're going to get 4 root 41 over 41. No further simplifying is possible, so we have the cosine value. Same thing for the sine value. We have 5 root 41 over 41, and that's the sine. So we have the sine, the cosine, and the tangent of this angle theta when the terminal side passes through a point 4,5. We did it. Let's do another. Let's do some more. We love this. Okay. Oh, look at this. Now, there are 3 more trigonometric functions, and they are reciprocal functions. So we have the 3 main ones, and then if you turn the ratios upside down, they're the reciprocal functions. So, the tangent was y over x. The cotangent, written cot theta, is equal to x over y, or the reciprocal of the tangent. These are called reciprocal functions because they literally are the original ones flipped upside down. So cotangent is not y over x, but x over y, or the same thing is 1 over tangent. The secant, which is written sec theta, is equal to r over x. Sine is x over r. Cosine is x over r, and so the secant is 1 over the cosine of theta. The cosecant of theta, written csc theta, is equal to r over y. The sine was y over r. So this is the reciprocal, or 1 over the sine. So you've got to know cotangent, which is the reciprocal of the tangent. Secant, the reciprocal of the cosine. the cosecant, which is the reciprocal of the sine. And you have to just learn those. So, the second example, which I'll let you look at, I'm not going to rewrite it out because you can do this. It says, find the values of 6 trigonometric functions of an angle theta in standard position whose terminal side passes through 512. So here we have the initial side of this angle on the x-axis, and we have the terminal side passing through 512. We've labeled the sides of our resulting triangle x, y, and r. We're going to use the Pythagorean Theorem with our 5 and the 12 to find out what r is, and it's actually going to be 13. Let me pencil it in. 5, 12, 13. Okay, so what would the sine be? Opposite over hypotenuse, 12/13. The cosine would be adjacent over hypotenuse, 5/13. The tangent is opposite over adjacent, 12/5. Now the cosecant is simply the reciprocal of the sine, so 12/13, flip it to 13/12. The cosine is flipped to give you the secant, so 5/13 turns into 13/5 for the secant. The tangent is flipped to give you the cotangent, so 12/5 becomes 5/12. We found all 6 trigonometric functions of this angle theta in standard position with the terminal side passing through 512. Okay, let me get rid of all that. Now, the next one, it says, an equation involving